Okay, we are live.
Mm-hmm. Okay, so torch lin alg dot vector is normally used whenever you need a single magnitude length scale value from a vector or from each vector in a batch. But
What? Can you repeat that?
it's normally used whenever you need a single magnitude length scale value from a vector or from each vector in a batch, like maybe an array of vectors that we have. By default, it computes L2 Euclidean norm. So the Euclidean formula that we have is going to use that to compute the normalization with the dimension. It computes that very along chosen dimension. Explain it to a 10-year-old. So think of a vector.
Efficiently calculates the magnitude of multiple force vectors all at once. Oh, I think I get it. So
Uh,
this is X, Y, and Z, like the force on X-axis, force on Y-axis, and force on Z-axis. And what they are doing is they are calculating this function computes the vector norm. By default, it calculates L2 norm, Euclidean norm, which is a
oh,
standard way
now it
to
makes
find the length or magnitude of a vector. For a 3D vector, the math it performs is root of this. Yes, force, this is your input tensor in the context of Isaac Lab setup. It is likely a shape numi nvs, comma 3. So that is the number of robots, comma the shape, which is going to be XYZ. That's why 3, I guess. Sorry, not 3. Oh, yes, 3. Okay. Force magnitude dot shape. Mm,
like I understood what it does, like how our robot uses it completely. How do you get it or not?
Like, I understand that basically the tensor for all the like this basically is gonna be for each robot,
Yes.
and this is gonna be the force on X, Y, and Z,
Yes.
right?
Yes.
And this is the force like force dimension, three-dimensional force for each robot.
Mm-hmm.
And what this is doing is this is basically um, calculating the direction and the magnitude of the force
Mm-hmm.
based on each of these arrays. This is like a list of arrays. Um, and then what do you understand? What do you
So based on like what I understood was, so for example, in this array, we will take those coordinates as let's say values where we made robot move in a certain direction, right? So let's say the robot went, the first coordinate was, I think, 3 4 0 on a graph, right? Or on a 3D dimensional system. When you're trying to plot what is the position of the robot right now, so it's going to
Mm.
be 3 4 0. That is x is equal to 3, y equal to 4, and z equal to
It's
0.
not a position. I don't think this is a coordinate.
No, no, but I'm just trying to, like, you can use it as a coordinate as well. Like, why are we using normalization? Like, what
Mm.
are we trying to do after doing normalization, right? So what we are trying to do here is
Mm.
we are trying to figure out what is the difference between the forces along different, I would say, uh, different variations or different time at different times. So for example, let's say at first position the robot exerted a force of some some value, like along three dimensions. So along x-axis the force was 3 newton meter, along y-axis the force was 4, and along z-axis there was no force. But in the
Mm.
second step the robot increased the force by 15, 20, and 0, right?
Mhm.
And when you want to compute the difference, to compute the difference you will normalize the value, that the tensor or that element, sorry, that vector to get a single value out of that. So when you normalize 3 4 0, that is, you put 3 square plus 4 square plus 0, you take an under root out of it, you're going to get a single value, right? And you can get
5.
whatever value you get, let's say 5, and then you can do it for every other element out over there, and you can get a
Mhm.
difference. So when you do 25 minus 5, you can get a difference that, okay, this was the difference in total force as a number between the
Mhm.
first step and the second step. And this is why we are using this.
Oh, I think I got it. Yes, 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 yes. Now I get it. This function computes the vector norm by default. Okay, L2.
Mm.
Okay. So 25 and 50. Why is there a dot? What is this dot?
5.0, 25.0, 50.0. Tensors are always going to be float.
Oh, okay.
They are not usually int, like over here. The data type they have is gonna be float because of the precision. Like right now, it's an example, but these values will be precise up to 4 or 6 decimal point, right?
Oh, and then minimum is 0 and the difference is 5 and 30
Yes,
over
yes,
here.
yes.
And because this is minimum is 0, that's why we are not calculating the negative value. Okay. And force penalty is equal to minus excess force. So force penalty would be minus. Okay, okay. That is basically reward engineering using tensors. You should immediately recognize some PyTorch primitives. These aren't AI operations, they are mathematical operations on GPU tensors. Okay, what is torque dot clamp?
I don't know. Let's take a look.
Force. This is your input tensor. Then I mean we were rows represent all rows represent all three column represent x, y, and z component of the one diagonal is equal to minus
It
one. This
keeps
tells
the
PyTorch
numbers
with
inside a
dimension.
safe range, like it's a min
Okay.
max function.
Mm.
That
This tells
number should
PyTorch
not
with
go, like the
dimension of
minimum value a
max.
tensor could have would be like 0, and we won't have any negative values like that. So when you clamp a vector out, so the values get whatever the minimum value is. If we have any value that
Mm-hmm.
is less than that, will be replaced with the minimum value that you're putting in the clamp. So torch or clamp, then you can input whatever vector that you have. Like for example, x is a vector, and you can put comma and then min equal to 0 and then max equal to 5. That is the maximum value that vector can have. So that's what clamping does over here.
Okay, dimension equal to minus one. This tells PyTorch with dimension to apply the math to minus one always refers to the last dimension of a tensor. For example, a num envs, comma 3 tensor, the last dimension is 3. The XYZ components. Okay, the result. Instead of returning a single number, the line collapses. That last dimension transforming your num env, comma 3 tensor of directional forces into a num env tensor. I know what's going on over here, but 1 second. Force mag. So this is just taking a Euclidean magnitude of the force. Okay. Indexing tensors. This becomes extremely important when reading Isaac lab code. ft tensor dot shape num envs dot comma 6. So ft tensor is what? fx fy. The convention is fx fy fz tx ty tz. Oh, torque. Okay. Force is equal to ft tensor, and there is this slicing over here of some sort. This means every environment 0 to 3 and 3 to 6 of ft sensor. So ft sensor means give me the column 0 to 2 for every robot. Oh, oh, okay. Give me the column 0 to 2 for every robot and force dot shape. Torque dot shape num envs comma 3 comma 3. You'll see the pattern constantly. Okay, I understand this. Now we reach neural networks. Your PPO policy is basically a function, observation, and then action. Or mathematically, this PyTorch represents neural networks using torch.nn module. Hmm. A very simplified actor could be import torch.nn as nn. Actor is equal to nn dot sequential, nn dot linear, nn dot elu.
Okay. But how do you open a split tab, dude? I'm not able to open split tabs.
Bot split tab.
Like you can split a tab, right?
Yeah.
Oh yeah, yeah, got it. Open and split view. Nice. Now I can do it. And I don't need you over here. I'm gonna do you over here. In recent years, several different approaches have been proposed for reinforcement learning in the neural network.
I'm just reading the abstract.
Mm-hmm.
Stochastic gradient descent. I want to understand what the fuck this
You
is.
know, not stochastic gradient descent.
No.
Yeah, let's take a look.
I might know it, but I might not
Like,
recall it with
I
the
can explain.
exact.
Like, if you go to images.
I think I know what it is.
No, no, just go to images.
Let me,
It's like much
is
more.
it something? Let me guess. Let me guess. So, and there are like a lot of valleys basically.
Uh-huh.
So basically, like whenever, like for example, this is a robot and it's learning, right?
Mm-hmm.
Okay.
Nothing, dude. I don't know. Something happened, and then
I can just see the back of your monitor now.
now you will be able to see everything. Okay, yeah, you're saying something.
Yeah. So do you understand what I was trying to say?
Oh no, you have to come again.
Bruh.
Oh, dude, what can I do?
Okay. So basically, if this is the agent
Mm-hmm.
over here, like this is our learning, uh, whatever you say, agent,
Mm-hmm.
right? It will go. You perform some actions to push it towards upward of the hill, right?
Mm-hmm.
And then you are here, and then you see, okay, you made progress, so you can keep going in the same direction. So
Mm-hmm.
you go more up, and
Uh-huh.
then you basically are here,
Uh-huh.
right? And in all of this, the parameter that you set was, okay, you have to get to the top of the hill or something like that, right? That was your end goal or something. And but you, because the agent is not that smart, so it doesn't realize that it's on the top of the mountain or whatever, right? And then it keeps going over here until it realizes, okay, now it's changing altitude, or now it's like going downhill, right? So you basically take a step back or do something, what do you say, like you basically step back and then you keep going in a different direction. And this is like a 2D, I mean drawing in 2D, but there might be another valley like this
Mm-hmm.
in, like, imagine 3D. So there might be something
Mm-hmm.
behind the screen which
Mm-hmm.
would be going upwards or something like that.
Mm-hmm.
So that's what I understand of what I recall stochastic gradient
No, dude, no.
descent is.
No, 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 no. So you're
Yeah, bro, it's the same thing. Yeah, this is the
no,
same
but
thing.
but the way you explained it is not the way that it should be explained. That's what I'm gonna say. Like
Yeah, but I
you
think
are
I
on the correct
remember
path,
what it
but
is.
it's not a correct explanation. It's not a correct explanation. You are saying, but so you are trying to reach the valley. The goal is that
Yeah.
we are trying to reach the go inside the valley. So what happens is you are
Iterative
total
optimization algorithm
total
used to
minimum.
maximize an objective function.
See, it's like walking downhill to find the lowest valley. Descent. So we are doing descent, right? Or ascent. Oh, my bad. We are doing ascent. So yes,
We are doing ascent, bro.
ascent. My bad. Yeah, you're correct. Using stochastic gradient ascent.
So I think I was correct.
Yes, yes, you are correct. You are correct. I was in descent. Like I was thinking about descent. That's why. Yeah, yeah, you are correct about it. Yeah, you are correct.
Okay, let's move. So this is basically, and yes, I want to understand this as well. Hmm. Let me open Claude over here. This is a standard reinforcement learning for robotics policy notation. Bro, did you ever do those derivations in physics?
I do
Like
recall,
Newton's laws of motions and kinematics?
I do recall it, but I do not recall it the derivation thoroughly.
Bro, now I'm thinking, bro, how could I have I done that when I was like fucking 16, 17 years old?
That's the magic, bro. That's the magic. I also.
Now I'm like,
But it's not that okay. It's not that. It's not gonna be that difficult. Like if you just put in some
I
hours.
know, bro, but like it is so crazy that I could do differential equations and all that stuff when I was like, I know it's not that hard. I think I will be
Yeah, it's
able
like
to do it
experiment. Like
again.
you, for okay, anything that you start doing is gonna be difficult on the first day, right? But eventually,
Yeah.
you keep looking at that thing, and then eventually it's gonna make sense. That's how programming was, I guess, initially.
Hmm. Okay. So PyTorch represents neural networks using NN module, and a very simplified actor could be actor equal to NN sequential, NN dot linear, NN dot ELU, So this is what, like a
Neural network, linear, ELU. So like these are the layers that you would put in. So you remember those machine layer perceptron, that diagram we had?
for transformers.
No, not for transformers. For our for our neural network.
Yeah, 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 yeah. The
Right.
artifact, cloud artifact.
Yes, yes, yes. So in that each and
Yeah.
every layer, this is the layer that we are talking about. So this is going to be a sequential layer that will have two linear functions and then an exponential linear unit function. Right. So this is like 24 256. That is the number of inputs that it's gonna take, and it's gonna export 256 output. That's how it does it over here. Exponential linear unit. A negative point, instead of flattening to zero, it smoothly curves towards.
Explain it to a 10-year-old in English.
No, dude, that was way
Max.
too much. Dude, way too much. Way too
10
much.
year old.
Fuck.
Okay, imagine you have a bunch of little robots, and each robot's job is to look at a number and decide what to pass along to the next robot. RELU robots rule. If the number is positive, I pass it along exactly as it is. If the number is negative or zero, I just say zero. I don't care how negative it was. -1 and -1 million, both are zero. It is like a very lazy hall monitor. Anything bad negative just gets flattened to nothing. ELU robots rule. If the number is positive, same as RLU, I pass it along as it is. But if the number is negative, I don't say just say zero. I give it a little negative number back based on how negative the original was. Really negative numbers still only get close to -1. They never go below that. But they don't get flattened all the way to zero either. Okay. Think of it like a bouncy ball versus a wall. RELU is a wall, anything negative just stops dead at R. Zero ELU is more like a slide and gentle curve down and levels off. Uh, oh, okay. It still lets a bit of negativeness through, just smooth out so it doesn't get too extreme. Why does it matter? These robots are inside a giant chain of thousands of robots. That's basically what neural network is. That are all trying to learn a task together, like recognizing a cat in a photo. If a robot's rule is too harsh, like RELU, always slamming negatives to a zero, sometimes the robot gets stuck. It starts always outputting zero and stops learning anything forever. That's called a dead robot. ELU's a smoother rule helps fewer robots get stuck and helps the whole team learn a little faster. But each ELU robot has to do a bit more math to figure out that curvy slide shape, so it is slightly slower to run than a lazy wall. RELU. Okay, we did RELU, right?
We did ELU, not RELU.
I think we did RELU, bro.
No, bro, we did ELU. Take a look at it over there. I do recall it. We did ELU, and in that artifact, it also says
Mm-hmm.
talked about ELU, not RELU.
Torch dot and end dot module. A very simplified actor could be import torch dot and then an actor equal to an end dot sequential. Hmm. Oh, dude, is the Odyssey available in HD now?
How long is it
How long is it? What?
for the movie to for the movie? Like how long has been since the
1
movie was
month.
released? 1 month, right? I think like in 10 or 20 more days we will have like HD everywhere.
Bro, I was trying to look at.
Do you know who is the partner? Like, because it needs to be on a streaming platform. Then only we can get.
I don't think it will be on a streaming platform this soon.
Okay, okay, yeah. Because once it's on a streaming platform, then only we will get. And the print is gonna be real heavy. Like, it's gonna be like 20 or 25 gigs, or at least 8 gigs, because it is.
Nah, I don't want to download it, bro. I just want to watch it in a
No, like if you
decent.
want that real good, like if you want like shitty, you can still watch it. Like if you want like pure like the IMAX print, right? Then it's gonna be like 7 or 8 gigs. Or otherwise, you can maybe use any subscription service that is over there that might host it. But you won't get that. Still, you won't still get that IMAX print. Like there are not a lot of uh, streaming services that will give you an IMAX print.
It's a very shitty brand right now. I want to watch that movie, but I don't want to.
I asked. I think our friend Tasmin, she went to watch that movie. She was like, you have to know like about Greek mythology and everything to understand.
No, bro. I don't think
No?
that's the case.
Okay, that's what she told me. So I don't know.
It's in a. I mean, it's scam, but it's decent.
What?
Print.
Hmm. Yeah, I know, I know. Like it depends upon you. If you're like, hey, I'm fine with this kind of a print, then definitely.
I don't know, bro.
Who else do we need?
Travis Scott is also in the movie, bro.
Oh my God, is it? Oh, Travis Scott is what in the movie?
He's some sort of prophet or something in the movie.
I see.
Oh. Okay. Fuck, my body is sore as fuck. Is your washing machine on?
Yes, brother. My washing machine is on.
I see. Okay, I understand this part now. For positive inputs, it's just identity like ReLU. So x is equal to x for x greater than 0. But for x smaller than 0, alpha of e to the power x minus 1. I get this now. So for negative inputs, instead of flattening to 0, it smoothly curves towards minus alpha as x to minus infinity with a typically set to 1. The output saturates at minus 1. Got it. So ELU is better than ReLU.
Mm-hmm.
Ignore the exact hidden sizes. So NN dot ELU. And what is it calculating basically over here?
It's calculating the tensors that you're providing, like the tensors that have that.
NN dot linear. What is this doing exactly?
So it's that's your neural network function. So it's a linear
Linear.
neural network. Linear, I don't know it. And then dot linear. It's a neural network layer or a function. And then dot linear. Wait, give me a minute. Let me just make sure that I'm telling you correctly. Is it connected and it learns and offline. It's an MLP. Yes, it's an MLP. It's an MLP. It's the
Okay,
same layer that
MLP.
we had in our artifact.
Machine learning perceptron.
Yes. And it's taking 24 inputs and then giving you 25 256 outputs.
Mm. Line of code creates a fully connected linear layer, also known as a dense layer, for a PyTorch neural network. Here is exactly what the numbers mean. Oh my bad. Bro, fuck. My body is in fucking pain today.
Where you go, where you go.
what the fuck? She's screaming a lot today.
All right, let's get started. Linear units, weight, matrix, shape, 25, 24. What happened, bro?
I'm just reading this in linear. Oh, okay, it's saying, oh, look carefully. An n dot linear means 24 observation numbers, 256 learned features. What does this mean?
So 24
So it gets
observations.
24 observation numbers that we feed it, and
Yes.
then it. But
Essentially,
what is 256 learned features? Where
so
does
if
this
you, if
go?
you take a look at the formula right over here,
Wait, let me also open our. Uh, do you know where we can see all the artifacts?
there's no such thing like all the artifacts. You would have only just version controls, that's it.
Okay, what were you saying?
So if you take a look at the formula right over there on your right, y equal to
Yeah,
x. So x is gonna be your input,
yeah.
right? And then you have a weight, so that's gonna be a random number, right? Like you can put
Mm-hmm.
define a weight, but for now it's gonna be a random number. And then the bias. So when you put the input and everything in over there, it's gonna compute a value for you, and that value is gonna be the learned feature from that thing,
Mm-hmm.
right? So it's doing that, and it's going to do it for all the 24 observations that it has, and it's going to create some kind of neural weight that, hey, when we put this input into this magic black box situation, there was a weight that was there was a matrix that was computed, right? And the more we play with those features, like the weight and the numbers that we created, the better our network learns about, like, okay, what happens when this inputs comes in over here, what how is this input related with other inputs, right? That is the most important thing a neural network learns. So when you have 24 observations or 24 input features, so for example, let's say one of the input feature is force, other input feature is angular velocity, and there's another input feature that is force threshold, something like that. So when you put, let's, we are just gonna put three right now. When you put this three features as an input into a 256 layer matrix, it's gonna do the
Mm.
computation, and it's gonna try to find, based on the numbers and the weight that we put, like, into the equation, what is the relation that we can get, what is the relation that exists into the into across each of these three observations or the input variable that we are given, based on the matrix or the numbers that are computed through this equation, that is the n dot linear equation. A
So
linear,
what? Where does the 256 come from?
what, 256 is the vector that we are going to create. We are creating that vector, we are creating it. It's like some, it's an industry standard, like how big your how many, wait, how many inputs or outputs are you going to generate from that 250, from that observation, that is what we can define. That is the vector shape that we are going to generate, right? So that's where it comes from. So we are going to define, okay, when we are trying to do this computation, we are going to put that value into the equation, and we are going to try to, we will be trying to create different kinds of a bigger matrix when we're trying to compute the value. So it's going to give you multiple values in a vector. Are you getting it? I think
Mm-hmm.
right, that's how you're trying to put, like, you can ask more about more to it. So the size of data coming out of it means the network is transferring. So yes, so it says over here, like, this is the size of data that we are gonna output from that layer using that. So it's like really complex. If you want to really understand it, we have to go into the maths of this, why, how this equation is getting computed.
I don't want to understand how the equation is created. I just want to understand what it is used for.
To create hidden layer, to basically figure out how each every other input is correlated with every other correlate with each other, like trying to figure out, okay, how are these inputs, when we're trying to put everything in every other parameter out over there, how does one input affects the other input as well, or what is the outcome when we are putting in two or three input and we are fine tuning. So let's say I'm giving you some values 1 2 3 4 5 6 as an observation, and I will say, hey, change the value to 3, change the value to 4, change the value to 5, and you're trying to compute for each and every combination that exists by adding a weight with that. So the main goal of this hidden layer is to find out basically relations between each and every input that you're trying to provide over there. And once you have that input, then you can basically compute other variations out of it as well. Okay, now we have figured out, okay, this input, if you're putting two inputs in this scenario, this would be the output that will be generated, right? And you can do it for n number of permutation and combinations for each and every output. That is the main goal for this machine layer preceptor, on that, to understand how each input matters to each other when we're trying to compute the neural network. And what happens when you basically weigh less on an input, and what happens when you weigh higher on an input, and how does it affect the vector shape and the values that the model is going to generate, or what model is trying to learn from that inputs that we are providing to it.
Imagine you're building a robot trying to put a peg into a hole of 24 robot basic senses. Think of 24 as the robot's raw senses. It has 24 little feelers or clues that it gathers from the world right now, such as my arm is raised high, peg is far away, blah blah blah. 256, the robot's brainstorming. The 256 represents bunch of new, smarter ideas the robot's brain creates inside the head. What an linear actually does. Imagine a giant mixing board with thousands of little dials. What a DJ uses to mix the music. The NN.linear is changing is that mixing board. It takes 24 simple basic clues, twists and turns using all the dials and mixes them together to invent 256 brand new complex clues. Instead of just knowing a simple fact, I feel pressure. The new mix of clues might mean something much deeper, like I feel pressure and my arm is tilted and I'm super close to the hole, so I'm probably bumping the rim. Okay, when your robot practices and makes mistakes, it isn't writing new code, it is just slightly adjusting those dials on the mixing board over and over until the it gets absolutely perfect mix of clues to slide the peg right in. Slide the peg right in.
Mm, dude, I, fuck. The only person I recall.
Legend.
One and only.
Ignore the exact hidden sizes I'm using only for illustration. Look at carefully. Okay, so that I understand, but why are there three of these? Like, I understand one, but why are there three of these? Are
So
there
now,
like,
once you have upshape, once you have basically upshaped your parameters, you have to downshape them as well. So that's why you have to, like, okay, you are moving from 24 to 256 vector shape vectors. Like, the shape of the vector that you have was earlier 24, or the tensor that you, like, 24 elements were over there, and when you transpose it through a neural network, you got 256 as your output,
mm-hmm,
and the number of the shape of the tensor went to 256. That is, the matrix size
mm-hmm,
is 256 into 256. Right now, you have made sure that every other parameter or every other combination that existed is being computed, but you want an output that is gonna be that, but you want an output in like a certain format, that okay, what happens finally. So what you are going to do, you're going to downsize your shapes. So you're going to move from 256 shape vectors to 128, and to do that
mm-hmm,
you will use n not linear, and you can
mm-hmm.
reduce it from 256 to 128. It will only go in the power of 2, because that's how matrix works. You cannot have 255 or 254 like as a shape, because it's going to break the matrix out.
I think I understand what's going on now.
Mhm.
So we received the 24 observation, and then we, at the end, we give out seven numbers again
Yes.
from that neural network.
Yeah.
Mm. Transforms its 24 raw sensor readings into seven physical movement commands. I see. Now I understand. Hmm. Policy training. Oh, I get it. 256 intermediate features or complex clues. And in .elu, the aha moment activation function. So ELU is an activation function.
Yes.
Got you. I got you. And .elu, another gatekeeper. Final polish. Okay. Uh, if linear layer is the mixing board, the ELU layer is the gatekeeper deciding which signal actually matters mathematically. It applies this function to every single one of those 256 numbers. Okay. Why it is conceptually. Why it is completely essential without an activation function like ELU, stacking multiple linear layers on top of each other mathematically collapses into one single linear layer on top of each other, collapses into just one single linear layer. Without an activation, stacking multiple linear layers on top of each other. Okay. ELU introduces nonlinearity. This allows your network to learn complex conditional if-then logic. It allows the robot to learn concepts like if I feel 20 newtons of force and my wrist is tilted, then I am hitting the rim of the hole. Node ELU is particularly popular in robotics or other functions like RELU because it handles negative values smoothly, which helps prevent jittery erratic movement in the physical simulations. And in linear 256, 128, the distillation. Now the network takes those 256 filtered complex clues and compresses them into the 128 higher level strategies. The network is essentially taking a broad brainstorm and narrowing down to the focus plan of action. And in ELU, the final polish, another gatekeeper, it applies the same mathematical filter to 128 final strategies. Exactly why which signals will drive the robot's physical motors. Okay, this final output it takes those 1 in 28 high level strategies and compresses them into exactly 7 numbers. Okay. For your peg insertion robot, these 7 numbers present in the actual command sent to the joints or end effector, typically in a 3D spatial task. This corresponds to 6 degrees of freedom plus an optional gripper state. What was roll? Roll, I know. Pitch. What was pitch? And yaw. Okay, summary of the procedure funneling the data through pipeline, observe, brainstorm, filter, strategize, filter, act. Observe and act. I get it. I see. Got you. I got you. I got you. The coolest part, batching just works. So OBS dot shape 4096, comma 24 action mean is equal to actor observation automatically gives action mean dot shape 4096, comma 7. Think about what just happened. One neural network processed 4096 robots simultaneously. So 4096 into 24 observations, actor is equal to actions are 4096 into 7. Correct. You don't manually call the network 4096 times. This batching model is fundamental to GPU RL. So what does this do? OBS dot shape. Hmm. Oh, this motherfucker, bro. Now it explains it. What
Create
does an dot linear
the
actually do?
value, WNB are the things robot learn, weights and biases, check them.
X is equal to num env. So 512 into 24 and then 256 24. B is 256. Num envs are 512. Okay, the values is inside. W and B are the thing the robot learns. W and B. Hmm. Check them. Layer n dot linear. Print layer dot weight dot shape. So layer weight and shape are 256, 24 and bias is shape. Okay.
The parameter in action dot parameters. Parameters. Parameters.
Oh, bro, this project is taking too long.
Rome wasn't built in a day, as you know. Mm. So good things sometimes take time.
Values WNB. Okay. Mm. Bro, I cut my
And
fucking, what do you say, inside of the cheek in boxing.
I don't know, bro. What's inside of the cheek?
Like inside, bro, over here, but inside.
Mm.
Like, have you never cut your.
Yeah, I have, but I don't know what do we call it. But I know what you're
Mm.
saying.
So every time I eat something, it fucking burns.
It
And
burns.
I think I will. What?
It burns.
Yeah, like
Like
it
it's
does not burn,
not
but it
normal.
like gets irritated.
Because you know why? Because we have saliva, and saliva is a really good painkiller. Like it act as a morphine. Morphine, I would just say that. So it should
Mm,
not hurt that much.
I
Make sure to
see.
like maybe drink a bit of water before eating, so that your mouth gets watery and savory.
Yeah, and I thought you were not gonna go that hard, so I was not wearing my mouthpiece, and I think I chipped my teeth as well.
Oh my god!
There's a gap, like a very small gap in my front teeth now.
Holy moly!
So now I will wear mouthpiece regardless of.
Hmm. I usually tell that insurance is really high, so we should not do any kind of activities. But no one will listen to me, and that's why. You know what I'm saying?
No, brother.
Fuck you, then, brother.
Hmm?
Nothing, bro. Nothing. Just messing around. Uh,
Uh, so we're approximately nummy and V's. Okay. Okay. The value inside WNB is what the robot learns. Layer is equal to nn dot linear 24 into 56 layer dot weight dot shape print layer dot bias dot shape 256 comma 294 256. There are Python's parameters for parameter in action dot actor dot parameters print parameter dot shape. Those are effectively the agent's learned knowledge. What does the activation function do? nn.elu multiple linear layers would collapse mathematically into essentially one big linear transformation, and activation introduces non-linearity. Allowing the network to learn things like if peg is left of the hole and peg is slightly tilted and contact force is increasing, then moving slightly right up, move slightly right up.
But how's your office, by the way?
What office?
How's your office like? How was work today, basically?
It's chill, bro. My manager and director both are on vacation.
Oh my god. Corey, you on vacation, brother?
But we are filing for a patent, and
Nice.
I was in meeting with lawyers all day today.
Oh, nice, nice, nice.
Yeah.
So, so have
And
you?
I was also reviewing SOW
So
for a third party organization that we are hiring.
nice.
You know what a SOW is?
Wait, hold on. I got a Teams message right now.
Did they realize that you are tunneling through a back door?
No, 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 I was just trying to say, is it you or is it me?
What? I'm not getting any messages, bro.
Oh, fuck, bro. I don't have any messages as well. Mm, you know, you should. Oh, dude, I was saying Tiger that hey, we do also discuss stocks. He was like, oh, you guys discuss stock. I'm like, yeah, but I thought you guys only do open USD. I'm like, yeah, and like in the middle, sometimes we might discuss stocks, like what we are trying planning to buy and everything. He was so excited.
Mm.
I'm like, okay, yeah, do you want to get into the call? And like, yeah, yeah, for sure, definitely for stocks. I'm like, okay, we would definitely bring in our guest angel investor so that
But that, I don't know, bro. He won't come in this late.
sometimes. No, dude, he's usually awake right now. Like he, on that day, I think on Saturday or on Friday, he was up till 3 making strategies out over there. Crazy
Mm.
ass strategies, the strategies that will make you millionaire
Mm.
one day.
For day one.
Day one day. Bro, fucking Walmart. Why we are not buying Walmart, I don't know. Walmart. I want to take a look at Walmart. Fuck us, bro. Fuck us. Walmart went from how much? What the fuck is this? 35 to 115, and like, dude, it's in up. It's in a fucking uptrend. Fuck. No worries, bro. But one day, oh John Deere, John Deere, Amar, brother from another mother, John Deere, dear John, John Deere. Oh yeah, by the way, I found my Kindle at my gym. It wasn't lost and found. So
Hmm.
nice.
What else was in Lost and Found?
There was a sunglass. There was some sunglasses as well.
Did
Uh,
you claim them?
yes, bro. I was like, hey, I have also lost some sunglasses as well. He's like, okay, how many? I'm like, two. I'm like, okay, take it. I'm like, yeah, these.
These two?
Yeah.
Oh, bro.
Why would you go for one when you can get two?
I remember I got our friend Tasmeen free AirPods.
Not Tasmeen, it was someone else, I guess.
No, it was Tasmeen, I
My
remember.
God, Tasmeen.
Yeah, she got free AirPods, bro, because of me.
Wow, bro.
Because I lost my real AirPods.
I know, you told me. But then you did
Yeah, Teddy found them. Teddy found them and he gave to the
the receptionist over there.
yeah the lost and found in student union.
Yeah, I know. Oh, dude, I think our documentation is ready. I'm trying to take a look at it. Ooh, interview defense. Hard questions, honest answers, and the evidence behind them. Two cross two ablation of force versus force penalty of PPO peg insertion. Four policies, three seats, 500 epochs. Holy shit.
Where is the documentation?
It's in docs. Interviewdefense.pdf. Before any questions and
Did
answers.
you push it,
Oh no, I have not. Okay, let me push it if you want me to.
or is it available on Jupyter Lab?
Yeah, it's available on Jupyter Lab. I can push it as well if you want. Whatever you go to docs, click on docs. Yeah, it's gonna be interview defense document.pdf.
Hmm. Yeah.
So this was generated by Opus agent, so it's gonna be like good, not feeble because I didn't think that this is a feeble job. Praises to avoid and their honest replacement. My policy is robust to domain shift. I have not run the OOD suits yet. The robustness half of the question is open. Oh my god. Item episode length evaluation. I have also I asked it to create glossary and everything for us. Task,
Hmm.
but I think it forgot to create it. Do we have any glossary? No, no,
Yeah,
forgot.
I can see a glossary.
No. Oh, there's a glossary as well. Nice.
Yeah,
But
but
it's not in a format
it's
that.
not a PDF.
Yeah, that's what I wanted, but that's fine.
But you
So
can still
I
see it.
called NVIDIA Forge Peg insertion task in Asset Lab and ran a controlled 2x2 ablation to separate two things that force aware manipulation usually bundles together, giving policy a
Did
contact.
you push it?
Wait, I have not. I can. I thought you were still taking a look at that. That's how I have not pushed it. Okay, but I will push it right now. Like, should I push it on the main or like on a different branch? How do you want to do it?
Push it on main. I think this is main only. You're on main only in Jupyter Lab.
Interview defense docs. Mid push. Done. Yeah, it's yeah, I did push it on main. You can pull. Yeah,
Mm-hmm.
yeah, try pulling it.
In main.
Yeah, in main. 3 minute version, caveats, attach, add, unprompted things, three things. A sharper review will otherwise find themselves absolute success rates are low. The evaluation suit is nominal, so nothing here yet measures the robustness. Robust, robustness, robustness. Wiper insertion. That is exactly the question. And the receptive because yeah,
Mm, career.
Did you go through it? Did you go through the?
Yeah,
Okay. I think it's not that great. Do you think should I update it or like make it more refined?
the glossary.
Yeah, no, not the glossary, but the defensive document. I haven't gone through the glossary yet. I was talking about the defensive document.
Let me see. Mm, it looks decent. It's not bad.
Hmm.
But I don't know, bro. It's a lot. I don't know. I have not read the whole thing. Fact
I know
sheets.
it's a lot. It's a lot. I know.
Okay, let's move forward in this. Oh, bro. Do you wanna do the other one for a bit now?
Yeah, yeah, we can definitely do that.
What was that? This one. सेल चलाने से पहले कोड पढ़ो. English. Motherfuckers. Turn that on, bro. Turn that port on.
Oh, yeah, yeah.
I'll be back. Fucking RELU and ELU and activation function and fucking reverse
And
input for
you
learning.
have a
Oh God.
visa as well, so fucking that as well.
What visa?
Like to get a job, you need the company to sponsor your visa as well.
I know, bro.
So that is also that is also a factor that you have to consider. Mm.
What happened?
Oh, it's not up. It's,
Oh, now it's up. Yes. Okay.
restart that bitchy ass kernel. ओ मेनू कर्नल चाहिए था यार.
Oh, that's NP torch. Ah, bearish news on flow. Bearish news flow on OpenAI. Anthropic just passed OpenAI in quarterly revenue for the first time, more than doubling to 11.6 billion, while OpenAI grew 18% to 6.7 billion.
So I have a different vision. I think I know where OpenAI is headed. So OpenAI is headed towards the trajectory of becoming a consumer-focused company. I would say that, like if you compare the UI of a cloud app,
What? For what are they becoming?
consumer-focused
Yeah.
from an enterprise-focused company, like they are really trying to get into.
Oh, Claude.
No, no, OpenAI.
Hmm.
Like if you uh, take a look at any product that they have, like let's go with a basic chat app, right? So the chat app has a lot of good UI, and they're trying to make it really easy for any user or anyone out over there
Hmm.
to message.
It's me, brother.
Oh, it's you.
Don't read it loud.
Oh my god. Oh my god. Oh. Okay. So what I was saying, yeah, so their apps and everything, it would be more like more of an Apple, like that. That's what OpenAI is trying to do, to bring in to create an LLM OS that basically replaces the operating system that you have. Oh, oh wow, bro. What the fuck? Oh yeah, nah. Fuck, bro.
Shadowban Boxing, the Hedgehog, has commented. We
What?
are back in business.
That this is.
Yes, brother, we are back in business, but we cannot start a business because visa problems.
Yes, brother. Visa problem, but no worries. We'll.
Let's also take a look at because we are not able to focus for a while, we can file issues for instructs in the meantime. And then
Oh, we
your
can
agent
update
can.
instructs, dude. Fuck it, dude. Yeah, you know what? Let's update instructs.
No, no, we don't need to update it right now. I'll just file issues
No,
and
like update, like in the sense our OpenUSD certification and all those things will be.
I know, bro. I know that's the thing I'm doing. Wait. Split. What the hell?
Tab to, like you have to do it in that window. Yeah. Oh yeah. There we go.
All right, physical AI workflows. From the data, your policy is missing to the moment it's deployed and moment it closed loop built for about everything and integrate dynamically AI company operating environment. Decision layer above the simulation stack. Have powerful simulation training and deployment tools, or they don't have a system to decide what to do.
What the hell, dude? Someone on Twitter was complaining that they gave their co-workers some kind of work, and the agent started watching YouTube.
I don't think that is true.
Okay, wait. You can search. You can search it up. Watching YouTube. Yeah, yeah, there you go. There you go. Yeah, this is the person. Oh, okay. So it gave him a task that hey, oh,
Ah, bro, it is not. Bah, bro. This is bullshit, bro. This is just too fucking, attention seeking behavior.
yes. It was in shots, not me. That gave the attention.
Rogue agent, bro. It's just fucking his system might have lagged. Oh, this is interesting. Hermes agent desktop can has a built-in browser. The agent sees everything you see. Open a YouTube video, ask for summary. The agent was this is nothing new.
Dude, yeah, let's open let's open that issue. Yeah, let's focus on that.
So for our landing page, I'm thinking let's put the vision on the landing page, bro,
Okay, we can do that. Like a video
and
or
like
something.
do some sort of, have you seen those websites where you click on the website and then it's just blank, and then there is a button that says try now or something like that.
But what are we gonna showcase them for trying now?
This vision board, but better,
Okay, okay,
just like dashboard.
okay.
Do you think we will be able to create a prototype now for this?
What?
A,
What
pro-
prototype?
a
Like the
prototype.
yeah, we can definitely, bro. Now we know we have figured out how everything works, what are the layers, and how ISXM and everything collaborates with every other library and integration tool that exists
Mm,
in the NVIDIA Omniverse. So definitely we can create. And your AirPods Pro battery are really low.
yeah, I know. So, what do you think? When should we start working on this?
First, just first create the issues or whatever that you're talking about, and once we have it in over there, then maybe we can I can spawn agents at the night that can start working on them asynchronously.
So, work in progress page, update the work in progress page to capture the OpenUSD certification completion for both Shaurya and Aditya. Mark all the modules complete and close that curriculum section in a collapsible, create a new tracker for the ISAC. Physically learning. Mm, yes. Mm, okay. So this is the first issue I'm creating.
Okay.
For the work in progress page, we'll add our certifications. Okay. Create a separate. Okay, I'm gonna create this issue.
Mm-hmm.
Bro, these experiments were so shit that we ran
Mm.
because we didn't know anything.
Yeah, well,
I don't know what the fuck.
we're just trying to do something, right? That's what happens, right? When you're trying to do something for the first time, that's how it goes.
Okay, so pillars page. Use Opus for this one.
Mm-hmm.
So I think us idea is still pretty unique. Like
Mm-hmm.
I've not seen any company right now, like as much as we have explored, I have not seen any company with this dashboard kind of thing. But the only question is how will this dashboard work if everything requires so much compute to operate on?
So there are some things that basically evolves over the time, right? So we are
Mm,
right now trying to build something that requires a lot of compute and is limited by memory and the other bottlenecks. But I'm
mm.
hoping that someone will, like any company or someone will come up with an efficient algorithm so that they are able to render out everything, or our the chip that we are using gets improved so that there are a lot of cost of optimization, other parameters, right? So that's the other thing that.
Because the thing is, if we are running, okay, let's say we want, okay, for example, we have this is our peg insertion project, right? We have our peg insertion policy, right?
Yes.
Over here.
Mm-hmm.
So the first thing that Drift Sentinel would do is it would take a look at, okay, the peg insertion robot is missing the target by, uh, you know, point 2 meters,
Yes.
and it's going to right of the hole. So basically, this is gonna capture all the details, right?
Mm-hmm.
And how would it do it? By basically, mm, it's gonna have to record it itself.
So for recording it itself, we are using ISXM, right?
Yeah, in ISAXM. But now I'm thinking that for the policy, the operator console for the closed loop. So 6 agents on one screen. Hmm. Now that I've studied the policy training, I think this does not make a lot of sense.
And that means our internship in our own self-funded startup was something. Shit. Drugs time.
Because like Drift Sentinel, okay, so here the main goal for Drift Sentinel was to basically capture the what do you say, the failures.
Yes.
But the failures would already be addressed in the policy training because we have already ran the neural network and it has already captured the failures and then basically redid the neural network and what we were seeing over here, um,
Mhm.
this basic function that we were trying to look at. Where did it go? What the fuck? Mm, This one. So like this is already doing what the Drift Sentinel would have done.
Mhm.
Already detecting the drift, and this is already learning over here.
Mhm.
So how will the Drift Sentinel work then? Or is it time that we ditch the Drift Sentinel or the idea as a whole?
Mhm.
Now it makes sense why we were not selected in A16.
Like you, dude. Dude. I think somebody did commented on the PR that I created for runnable notebooks. Even though I closed that issue, and they're like, "Yeah, we are taking a look into your PR." I'm like, "Bro, you are gonna again fuck me up."
Generation plan 8000 new, 1200 reuse, spend forecast 540 GPU edge, coverage delta plus 14%. Approve gap report. Scenario architect diagnostation confirming failure mode on irregular SKUs. Hmm. Hmm. Bro, this will require a lot of time.
But do just create the issues. Like it will
But
require
what do I create? Okay, wait.
like,
For the pillars, I will
whatever
just
thought
create.
process you have. Just create, like speak it up.
I have created two issues
Okay.
right now. I'll create one more. Like, let me see. Because for this, I mean, it's correct. It's not wrong, but mm, wait, man. Landing page. The decisions about the simulations. Can we attach screenshot in the
Yes,
issues?
we can. Paste. Yes. Oh, okay, okay. Yeah, it's gonna be over there, I guess. It's gonna be in your user attachments. Once you create it, it's gonna pick it up directly. Go to preview, you can see it, I guess. Click on preview. Ooh. Click on it.
No.
String. Oh, because the repo is private. The repo is private. That's why we cannot do it like that. So what you have to do is create another repo and then link it. That's how I did it at my workplace. It's not gonna work like that.
I think it will work. 1 second. The fuck. Yeah, now it worked. See, bro. This is how you need to
Oh, you put paste with the image. I see.
look at this. You need the need the diagram to be updated and you can see the logo. You want to proceed. Failure. Yeah, bro, I think we put some AI slop over here. This is a lot. I think this makes more sense.
Okay. We need a
Failure
diagram to link
detection,
it.
scenario generation,
Yeah.
simulation run, evaluations, and then redeployment instead of this shit.
Okay.
1, 2, 3, 4, 5. Coverage gap analysis. Why do we have three different things? Hmm?
What three different things?
We have this full cycle over here,
Mm-hmm.
and this one makes more sense actually.
Mm-hmm.
Drift detected, gap identified, generation planned, scenario generated, scenarios validated, policy retrained, readiness signed off, redeployed. So this is one cycle. And then we have these four pillars as well. I don't know for what. Symptorial evaluation, closed loop retraining. You know the people who won the hackathon,
Mm.
they built the same thing.
Mm. Bro, I did ask you, should we go? And you're like, you go. And then I'm like, okay, no one will go.
Bro, it was in Seattle first of all.
Bro, we R&D. R&D. Burn.
It was in Seattle, and first of all, you had to get approved for some.
We would have made some calls. We got some big connections.
That's true.
Hey, bro. Because they already knew that we are certified and like. So the thing is, what I don't know, I might be wrong. What people look for is like do the so
It's good.
do these people have the thing that that they can do something, right? Like, okay, they talked about open university, were they able to get the certification? Like it shows the impact, right? Okay, they are doing a full-time job, and as well as they're trying to get into robotics as well. So these are the small things that people see. So that's why I think that people do value what we are doing and do value our work and our achievements, right? So that's why we would definitely have a greater impact, or maybe more, I would say, inclined favor agreements. Say if you're asking, hey, can you get us in? You're like, okay, I think I have seen these guys in person, and I think they have that kick or something in them, and then definitely we should give them a try. So that's what I see it as, because again, your network is your net worth. And do correct the spelling of scenario.
Where?
There's the red squiggly lines, and it's S and A.
I know, bro.
Yeah.
And so I'm just trying to remove excess fluff, bro, because this is a long landing page. I don't want it this long.
Okay, yeah, we can definitely like trim it down as needed. But I have to clean up my house a bit. Fuck. Shit, bro.
Remove the architecture block. Four pillars, six agents that operate. Can you hear that?
No, bro, I cannot.
It's good. Yes, bro, you guys are doing it. The Bastion Moreton. Thanks, man. He just commented.
Crazy, bro.
Mm.
What did you tell me? Fuck it.
Remove the. I think we don't need to we don't need to name our agents.
Hmm.
Four pillars. X agents to operate them. Oh, by the way, Edmar was asking me to apply for this media inception.
Yeah, bro. Oh, yeah. Then let if he was asking, but for this you need you need all of these things.
What? Yeah, we have this teams.
Oh yeah, yeah. Okay, damn, that would work. Yeah, definitely. Let's do that as well because it's gonna give us like the promotional credits and everything. What the fuck? Wait, open it.
They have different. A fucking.
Uh,
I think we need to change our
yeah,
name.
that's an issue as well. Yeah, create an issue for that.
But what would be our name?
We won't put LinkedIn over there. Like we cannot put a LinkedIn page, create a LinkedIn page as of now. We can, but I don't want to create it. It's gonna,
I think we did see this
yeah.
somewhere. I think they're from North Holland. We officially incorporated.
Mm.
Should we do this? to get incorporated. Hmm. Just want the transcripts, bruh. Give me the transcripts. So, if we did this, will we officially be a company then?
Yes, I guess so. But I think
Thank.
when you're trying to register, they're gonna ask you a lot of information. That's
Mm,
that's the thing that would be a bottleneck, and it's like, what's that? You have a meeting right tomorrow with the DSO. So yeah, have a talk with them once.
and ask them what.
Ask them that we are planning to do this. Like you can share your screen as well. Like, do we have to declare anything or something like that? Because dude, you're on stamp duty,
Mm.
right? So like doing these kind of stuff is like kind of you need approval first of all. Like we need to be clear of that. It's not gonna cause any issues in long term.
For me, long term is 9 months, bruh.
Yeah, yeah. So for that as well, like even for that, 9 months, right? Even if you're trying to get something, if you're trying to get somewhere.
Okay, let's create this issue. 3 issues are live. I'll also create one for. Uh,
Hmm.
The latest projects we have been working on here, along with the research papers, we have been implementing a policy model to formalize the we are using first product papers. Okay, I've created 4 issues right now. Let's
Okay.
get back to our thing.
Bro, do you have anything tomorrow? Like, how long is it? It's 2 a.m. because.
Let's just do 1 or 2 steps of this and then we can end it.
Okay.
I'm just trying to get this back on track. All right. So we were on the second step and we were trying to understand. Okay, क्या करना है? Set up training environment via cell को पढ़ो. No container needed. Training runs in this process on the local GPU. No container needed. Training runs in this process on the local GPU. This cell enables the throughput knobs that matter on Blackwell. TF32 Matmul CUDNN auto tuning and measure what the device actually delivers. So the epoch time estimate in step 6 is grounded in a real number. Hmm. What the fuck does that mean?
Which job are we trying to do?
Step 2. Training runs in the process local GPU. The throughput knobs that matter on Blackwell TF32, Matmul, CUD, and auto tuning. And measures what the device actually delivers. So the epoch time estimate in step 6 is grounded in real number. If device.type is equal to CUDA toss.backend CUDA matmul allows TF32 is equal to true. What does this mean, bro?
TF
Okay, matmul
Math
tensor core.
CD मैथमल कोर्स पर TF32 यूज करे कॉन्वोल्यूशन के लिए भी वही एंड कौन एल्गोरिथम्स ऑटो ट्यून करे बैकएंड्स
What is matmul tensor and what is TF32? Matrix transformation in the tensor context usually refers to the core operation C is equal to A at the rate B performed on tensors multidimensional arrays rather than plain 2D matrices in deep learning frameworks. PyTorch TensorFlow Jax matmul generalizes matrix multiplication to batch tensors. Example tensors of shape batch mk multiplied by batch kn gives batch mn doing many matrix multiplication in parallel. This operation is the computational backbone of neural networks. Every linear layer attention mechanism qk to the party mention at the rate v and the convolution when unrolled reduces to matmals because it dominates compute cost hardware vendors. TensorFlow 32 is a numeric format introduced by NVIDIA starting with the Ampere architecture AG100. Okay, I also wanted to ask this. Programming.
matmul multiplication explain GPU architecture that I should with regard to CUDA for the project I'm preparing here teach it surgically so
Python stress tensor mathematics. CUDA turns that math into massively parallel GPU work. GPU architecture determines whether that work is actually fast.
fast that work actually fast bitch
Uh, Bro, do you want to see something cool?
Sure, brother. Why not?
Wait. I'm gonna record a video using that.
Uh huh.
Where the fuck is that?
Dude, that this Doom trailer is so freaking awesome. I have watched it so many times again and again. Yeah.
Why, bro?
Bro, I don't know, bro. Like, I think like I usually don't. I have stopped watching Marvel movies for a while, but I think I would definitely watch Avengers Doomsday.
I see.
Yeah.
Okay. Talking of Iron Man,
Hmm.
I have something interesting. Can you
Wow.
see the screen?
Yes. This is something that you created, or oh, nice.
And then, why is it not working?
Oh, it's working. Oh, okay, okay.
But wait,
Oh, I know what you're trying to do. Like you're trying to open it up. Oh, nice.
why is it not opening? What the fuck?
3D rotate your hand. It's saying.
Yeah, now it's opening.
Okay.
Okay. It's not perfect yet.
I know it's fine. Like
Why
you
is it
should be
not?
able to like, tap like this, right? You know, tap.
Yeah,
Oh,
now.
there we go.
Okay.
Ah, cool stuff, bro. Uh,
Right.
that thing is kind of buggy. Like you cannot pinch it perfectly. Yeah, I know.
And it's like, yeah. Oh, you see?
Nice.
So I can do this shit. You know, that day I was talking about
Yeah,
Jarvis.
yeah.
I can do it with my hands now.
Nice. No, but this is not like picture perfect, right? Like it's not.
Obviously, bro,
But that's
obviously.
why I was saying, like, if you have motion sensors, then it would be like precise AF, right?
Yeah.
So that's
But
why I was,
like, this is very good, like, for
that's
this.
you said it, why does it exist? I said that it exists, but it's kind of costly right now. Okay. Okay.
So I can do this.
Nice.
And then, I mean, it starts becoming a little better
Uh-huh.
once you use it for a while. No, bro. The fuck? And I think you can reset it
Like
with this
this,
or something, with clap or something.
only one camera found. See, it needs like a three-dimensional view of you.
Yeah, I think it needs like at least three cameras. One. like one on left and right and one in front
But it's not
of
able
it.
to, like,
And then
when you're trying
all
to
three
picture,
of them
it's not
need
able to find
to,
out that exact location of that point.
yeah, and then all three of them need to have like a, you
Peripheral
know,
vision, I guess.
peripheral, like all the data.
Nice. Yeah, yeah, yeah.
But yeah. And it's also because I was looking in front and not looking in the camera.
Yeah, that's why it's still like we need at least two cameras to cover up everything, I guess.
But it's still fun. But yeah, I didn't waste a lot of time on that. I just found the Git, and I was thinking of putting in some time, but I was like, nah, fuck that.
So you created that on your own.
I
Oh,
found a Git,
oh, you formed the good. I see. Like,
but it's very easy. I think you can do it on your own as
I
well.
know how to do. Like it's like you're taking two or three features, and then yeah, I know how to do it because I have seen a lot of people do the same shit, but on a basic level.
Oh, okay. Yeah, we were studying this tensor float. Mantissa bits. Oh no, we are not studying this, bro. You're looking at this, yes. Study graphics pipeline, rasterization, hardware regeneration, and a target model. This is your robotics code, iCycla, PPU, learn PyTorch, CUBLAS, UDN, and
QBLAS,
CUDS.
yeah, QBLAS is the library that does the multiplication. I know this because I did complete the partial video of that guy who we learned about large language models. So QBLAS
Mm.
is the library that you does the math model thing for us.
But he didn't show CUDA programming, did he?
So, dude, there is another
Yeah, another video. Yeah,
boot camp
because I
that he
remember
does.
I
It's like
did that
12
video.
hours, and in that he taught me like literally from scratch how you can do a matrix multiplication in C++. Like how
Mm.
each index is like the same thing that it is teaching right now, but more detail and granular level.
QBLAS, UDN, and CUDA programming, GPU hardware, SM, warps, threads, FP units, tensor code, registered, shared memory, cache, VRAM. Once click become connected rather than isolated terminology. CUDA itself is NVIDIA's parallel computing platform programming model. CUDA programs start on the CPU and launch kernels that execute many GPU threads in parallel. So, okay, start with the fundamental difference CPU versus GPU. Imagine if you have a this calculation yi equals to x to the power I for 10 million values. A CPU is designed to be very good at executing complex sequence instructions with relatively few powerful cores. There are a million of similar pieces of work. Do many of them at the same time. So conceptually, CPU is Z x0, x1, x2, x3, core 1, x, okay, core 2, thread.
thread 0, thread 1, thread 2, and then thread 999. This is exactly why GPU fits neural network. A neural network is only made of with this equal to AB matrix multiplication. There are enormous number of independent arithmetic operation available
How
to.
is this matrix multiplication?
Yes, brother, that's matrix multiplication. So you are multiplying weight is a matrix. So you can take a. I will show you. Okay.
So let's say this is a 3 cross 3 matrix, right?
Yes.
And we have this one cross 3
Yes.
matrix.
Yes.
And when I multiply them,
Yes.
do you know what happens?
Yes. It's gonna be so the formula goes like go up a bit. Type R on the top of the first matrix.
Okay.
Yeah. And column on the side of the rows over here.
Oh, like C.
Yeah.
Yeah.
Right. So what it's gonna do? It's gonna do row cross column. So it's gonna first pick up x1,
X2, X3, right?
right? It's gonna be y1,
Mm-hmm.
y2, y3,
Yeah.
right?
It's
So
gonna be X1 comma into
y
the sum of Y1 plus Y2
no
plus
no no
Y3.
no 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 yeah that's where you're wrong. It's gonna be x1 y1 x2 y2 x3 x1 y3. Oh yeah, basically yeah, that same thing, same thing.
Bro, what the fuck?
My bad, my bad, my bad, my bad.
Are you fucking?
Same thing, same thing. My bad. I was, I
Yeah.
was, I was wrong. Now you're doing it across x1, y1. Now you're gonna do, but you don't do it y1, y2, y3. You will do row and then column. So you traverse first first element and then you traverse down the second element, second matrix. So it's not gonna be y1, y2, y3. It's gonna be y1, uh, z1, and what's the other like a1 if you want to go with
F1.
f1. So it's going to do y1 z1 and f1, and then for x2 it's going to do the same, for x3 it's going to do the same, and it's going to do it until it completely traverses the matrix in the same manner. So that's how.
Bro, wait, I think you're wrong.
No
I
no no
think that's
that's how
me.
it goes, row into column. That's how matrix multiplication works. Row into column. See,
Wait.
1 into 6, 2 into what the fuck,
Yeah, 1
1 into 6.
1 into 6 plus 2 into 8 is equal to 22,
Yeah.
right?
Yes.
1 into 6 plus 2 into 8. Why is this getting multiplied over
No,
here?
that's what I'm saying. That's how the matrix multiplication works. So you see one
Oh,
2 into 7.
1 into 5, 2 into 7, and then 3 into 5 plus 4 into 7, 3 into 6 plus 4 into 8. Okay, and that's how the matrix multiplies. 1 and 3. Okay. 2 cross 2 into 2 cross 3. So 2 and 2 match. So 2 cross 3.
So I think you should take a look at the look at an can you open the third image over here? It's gonna explain you much better. Yeah. There we go. Dot
1,
product 2, 3. Yes. So
1
1
into 7
into
plus
9
2
and 3
into
into
9 is 18. So 18 plus 7 is 26.
3 into 11 is 33.
26 plus 33 is 58. Correct. This is dot product.
Yes.
Okay. Right. So how is it connected to the formula over here?
Now Now over here, so W is a matrix, X is also a
Mm-hmm.
matrix, B is also a matrix,
Mm-hmm.
right? So when you're computing W dot X, not W, it's W dot X. So you're gonna have a matrix multiplication over here plus
Dot product.
bias, that is also a matrix that will be added as a constant. So whenever we are trying to compute weights of our model, right? So we will definitely get some kind of, we want to add a noise into our model that will basically give them a bias that, hey, this is gonna
Mm-hmm.
be what it would look like. If you do not add a bias, it's gonna hallucinate a lot. That's why we always have to add a constant like plus C plus b,
Mm-hmm.
right? In quadratic equation we usually had a constant, right, that was over there all the time, whatever the value is. So similar to that, we have a constant bias that is always added after a dot product is done in a matrix, in a neural network. So y w dot x, that is the dot product of two matrices, plus b, another matrix that is a constant. That's how the matrix multiplication works over here.
I see. Linear layers. The SM is the GPU concept I want you to remember. Do not think of NVIDIA GPU simply as 20,000 CUDA cores. That model will confuse you. Think GPU as SM, as streaming multiprocessor. And SM is effectively a little parallel computing factory. NVIDIA describes the CUDA hardware model as collection of SMs. An SM contains a register file, cache, shared memory sources, multiple functional units that perform computation inside an SM, conceptually streaming multiprocessors. Warp schedulers, register, shared memory, FP30 arithmetic units, CUDA cores, integer units, special function units, tensor cores, different NVIDIA architecture change the exact counts of an organization. So don't memorize those numbers, memorize the hierarchy. Threads, warps, blocks, grid. This is the most important piece of
Oh yeah, this is the most important concept over here.
threads, warps, blocks, grid. Threads, warps.
How would you write
So C++, global void. Okay, so CUDA is basically C++.
yes.
You don't execute this once. You might tell CUDA square of 30907 256, which roughly means create 3907 blocks, each containing 256 threads. So this is the most important piece of CUDA programming. Suppose you write CUDA function, okay. Mm. Okay, so basically you're just saying how many so basically CUDA is like a language in which you can relate to the GPU of how to use its threads
Yes, and how to do the
efficiently.
matrix multiplication.
Yeah, so that it is like using the least compute for the most efficient output,
Yes, yes, yes,
so that it trains faster.
yes. And that's why like Nvidia is leading, but I guess Huawei is gonna take over soon. Like
Mm.
this is why like every other Nvidia GPU is leading out over there in the enterprise industry because of their CUDA libraries.
Mm. CUDA calls the GPU function a kernel. Kernel launches create many threads are grouped into blocks. Blocks form a grid. Every block executes an SM. So, what is an SM? Streaming multiprocessor. NVIDIA describes the CUDA hardware model as a collection of SMs. CUDA hardware model is a collection of SMs. An SM contains a register file, cache shared memory resource, and the multiple functional units that perform computation. Streaming multiprocessor has warp, register, shared memory. Okay. Different NVIDIA architecture, so tensor cores, special Threads, verbs, blocks. This is the most important piece of CUDA programming. Suppose you write a CUDA function. Okay, do you want to execute this? You might tell CUDA this, which roughly means create 3907 blocks, each containing 256 threads. CUDA calls GPU function in a kernel. Kernel launches create many threads. Threads are grouped into blocks. Blocks form a grid. Every block executes on SM, and threads within a block can efficiently communicate through shared memory and synchronization. Hierarchy grid block 0, thread 0, thread 1, thread 255. Block 1, thread 0, but hardware introduces another level. Block 1, 0, 32. The block contains 32 threads.
Grid block 0, block either are.
So grid is the highermost, then block, then thread.
Yes.
But this is grid, block, warps, and thread. Why is it in the opposite order then? Threads, warps, block, and grid.
So it's looking up, not looking down. It's looking up.
I see. Hierarchy is so CUDA calls the GPU function a kernel. CUDA calls the GPU function a kernel. Kernel launches creates many threads. Threads are grouped into blocks. Oh, and blocks form a grid. Every block executes on SM. Every block executes on SM. And threads within a block can efficiently communicate through shared memory and synchronization. But hardware introduces another level, block
RAM
warp
is
32 threads.
32
A
warp.
warp contains, okay, so between block and thread, there is also a warp in which each warp contains 32 threads. On NVIDIA CUDA GPUs, the SM schedules and executes work in these warp size groups. The SM schedules and executes work in these warp size groups. This distinction is extremely important. CUDA thread is not is equal to CUDA core. Okay, a thread is software execution context. A warp contains 32 threads. Okay, CUDA thread is equal to CUDA core. It's not equal. Why warp matters SIMT, where here's where GPU programming starts becoming interesting. Suppose 32 threads form one warp, they execute this. Beautiful. Yi is equal to xi into 2. All 32 threads perform essentially the same instruction on the different data.
So each instruction over here is you can compute it as as a matrix multiplication of a tensor.
Like thread,
Yeah, no, x0 is gonna be yes, yes, yes. So each thread is doing a single matrix multiplication.
this one.
Yes, and you have 32 threads that are running synchronously in parallel.
Hmm. Oh, normally when you do math, you multiply one number by another. A matrix is just a giant grid like a massive spreadsheet of full numbers. Matrix is a mathematical trick to multiply those thousand number of grid A with the thousand number of grid B with the exact time to get a brand new grid. Grid C, if you have to 10,000 multiplication problems, you would have them one by one. Matrix multiplication like super over that you know, 10,000 problems in one single snap over and the magic recipe is okay. This is the one. So suppose 32 threads form one warp. Here's where GPU programming. What is SI? Okay, single instruction multi-thread. So yi is equal to xi plus into 2. So y0 is equal to x0 into 2 is thread 0. Okay. This model is called single instruction multi-thread. So now imagine if x of I is greater than 0, expensive function A, else expensive function B, and half the warp wants A while half wants B. The warp has diverged. CUDA may have to execute path A for the one subset and path B for the other subset. Efficiency occurs when 32 threads follow the same execution path. Divergent branches force different paths to be executed with other lanes inactive. This gives you your first GPU performance law. GPUs love a lot of identical mathematical work on different data. I see. Oh, notice how perfectly neural networks fits that description, correct? Ah, so this is a law. GPU loves a lot of identical mathematical work on different data.
because they can do the same task parallelly. So that's how we are able to compute different scenarios all at once.
Hmm. I
Bro, it's
s-
2:30, bro. Let's finish this shit.
Yeah.
Now connect this to your pill insertion PPO project.
Okay, now connect this to your peg insertion PPU project. Suppose you simulate 4096 peg insertion environments and every environment reduces 24 observation values, observation shape 4096 into 24, and then linear 24 into 56, 4096 into 24 into 24 into 256, 4096 into 256. Okay, there's an enormous collection of multiply and operation that are largely independent. The CPU, there's a lot of arithmetic. Excellent. Give me thousands of parallel pieces of work. ISAC lab itself is designed around vectorizing RL across large number of environments and supports end-to-end GPU RL training across thousands of environments. So the architecture starts becoming GPU physics, PyTorch, positions, velocities, contacts, forces, tensors, actions. GPU-enabled ISAC physics can also offload physics calculation to the GPU, which is keeping the RL pipeline device side so powerful. The second architecture concept. Okay. Okay, I think we can end over here and continue from there tomorrow.
Yeah.
And let me just see where is our oh yeah. Shit is fucking we are so okay, tomorrow let's do this first.
Mm-hmm.
And yeah, we can the goal is to finish these two projects
Mm-hmm.
completely to end with like everything understood.
Yes, that's the goal.
Synthetic data generation and then fine tuning a model with that, and then training our own policy model based on the training done on ISAC lab on EGX Spark.
Mm-hmm. Bro, this arm is so awesome. You can move it easily.
Okay, let me end the stream.
Word, bro. Is the stream ended?
Not yet. 1 second.